Okay, here we go with the next testing of the wood specimen. Normal is a word that comes in a lot of different ways, but in this case, normal means kind of with loading it with the grain. And you can see that
0.908.
Ed is doing an experiment today, and it's pretty impressive. I'm impressed by this, that he can measure with his right hand and record the measurement with his left hand. He's a pretty talented guy. But very important to notice here, he measures both sides. Just because it looks like it's square, don't assume that it's square. It's always good to measure both sides to get both of those dimensions. It's also important to note that every set of dial calipers is a little different, and they're all difficult to read. So take your time, measure some big things, some little things, and so you can really learn how the scale works, especially the inches scale, the tenths scale, and then the hundredth scale, which is what shows up on the dial. So he's getting all those measurements down.
Yes, and one more thing.
Again, it's a lot easier to do this before you put
when you see the failure mode, you can stop the test prematurely, like it stops.
Right. I'm not sure what Rahul's explaining now.
Breaking modes.
Oh yeah, he's talking about the different types of failures, right? It could split along the grain, it could crush along the grain, and then it can broomstick. Where remember we consider this wood as like kind of a bundle of straws, and the individual straws can fail. The straws can fall apart. That would be called broomsticking. Now Ed is raising the platen, so there's room to get that specimen right in the center.
No, he did not.
Another view of that. It's funny, I wasn't there for the recording of this video, so I'm not sure why we showed that part twice. But it's important to get it right in the center, and then slowly lower that crosshead down. Best to do this on low speed, and then the thumb wheel for the very end of it, until there's, looks like you've got too much load, and that's why he's going up with the thumb wheel right now. I want to start somewhere in the ones of pounds. And classic mistake, right? Forgot to turn the handset into local mode. We'll try it again. Now he runs the experiment. He wants to enter a sample ID. Ed, Dave, and Rahul are all grad students, so they're very used to giving their data files constructive names. He goes through and enters the dimensions, the length of a side. We're assuming it's square here, length of the side and the height of the specimen. And then the process starts. I think the blur was a time-lapse thing. Yeah, now I can see it's up to 1,400 pounds, 2,000 pounds, so considerably higher load here. And then right about now, we see a big drop in the load, and if you look closely on the right view here, you can see there's kind of a discontinuity at both edges. The upper left edge and then the mid right edge. It almost looks as though there's a 45-degree angle connecting those two discontinuities. And sure enough, now in this view, we can see there is a line there. This is kind of a neat. No, the method stops as soon as it detects a big drop in load. The method, the crosshead stops moving and the test is over. So Ed raised up the platen, and this is a great example. Even though the load was applied vertically, it failed at this neat 45-degree angle. You'll learn in a few weeks why that happens, but it's very, very interesting, and we're kind of lucky that we got one of these. Now, of course, he goes through and saves the data. File, export, preview, save, specimen, and you get that text file, which then we can open up in some data processing package, Excel, Sheets, MATLAB, whatever. But always very important that you save that data, and then, of course, the universal 307 thumbs up.